Unit 4B, Lesson 4. In this lesson, we're going to use probabilities to make fair decisions. So if we're given a few different options for ways or methods we could use to make a decision, we want to determine out of those options which one is going to be the fairest. On to the first scenario. Peter, Austin, Jason, and Matt each want a different type of pizza. To help them make a decision, Peter pulls out a standard deck of 52 playing cards. There are 4 suits of 13 cards each: spades, clubs, diamonds, and hearts. Spades and clubs are black, while diamonds and hearts are red. You want to determine which method or methods are fair from the 3 listed below. Method 1, 2 cards chosen together and looked at one at a time. If they are both red, Peter decides. If they are both black, Austin decides. If the first card is black and the second card is red, Jason decides. If the first card is red and the second card is black, Matt decides. This method turns out to not be fair, and we're going to look at the probabilities to determine why this method is not fair. We're going to look at the first scenario where Peter would decide. So if both cards are red, in the standard deck there's 26 black cards and 26 red cards. So for the first card to be red, there would be a 26 out of 52 chance of that card being red. Now we want to multiply that by the probability or the chance that the second card is red as well. And that would be 51 because we already removed that first card, but now there's only going to be 25 red cards. Now we're going to compare that result to Matt's decision, where if the first card is red and the second is black. So for the first card, there is still a 26 out of 52 chance that that card is going to be red. But now the probability that the second card is going to be black, if we remove the first card, there's only 51 cards left. But the first card was red, which means there are still 26 black cards out of the remaining 51. So we can easily see that these two situations are not going to be the same. So that's why this method is not going to be fair. Now we're going to take a look at the second method. One card is chosen. If it is a spade, Peter decides. If it is a club, Austin decides. If it is a diamond, Jason decides. And if it is a heart, Matt decides. This method is going to turn out to be fair because for each of these suits, there is going to be an equal probability of 13 out of 52, which would simplify to 1/4. There's 4 different suits for cards. Each suit has 13 cards in it, so there's an equal chance that that card would be a spade or a club or a diamond or a heart. So method 2, we'll circle that because that one's going to be fair. Now we have to move on to method 3. Cards are repeatedly drawn and then discarded until a spade is drawn. If a spade is drawn on the first try, Peter decides. If a spade is drawn on the second try, Austin decides. If a spade is drawn on the third try, Jason decides. If it takes 4 or more tries to get a spade, Matt decides. Logically looking at this method, it's not going to be fair. Okay, we have different turns that people are taking for that spade to be drawn. Matt would get 4 or more tries to get a spade, but it's still not fair because if the first card had been a spade, then Matt doesn't even have a chance to have his decision met. So there's just no way that method 3 is going to be fair. So the only method that would work for them to decide who would get to determine the type of pizza they're going to get is method 2. On to the second scenario. A magician performing at a birthday party stands inside a circle of 14 kids. He's going to choose a volunteer, and he wants each kid to have the same chance of getting chosen. So we want to determine which method or methods are fair. Method 1, the magician starts with the birthday boy and moves clockwise, passing out 65 pieces of paper numbered 1 through 65. He cycles around the circle until all the pieces are distributed. He then uses a random number generator to pick an integer 1 through 65 and chooses the volunteer with that number. This method is going to turn out to not be fair, and we can just do some basic division to see why. So there's 65 pieces of paper he wants to pass out. If we divide that by 14, the number of kids, we can determine how many pieces of paper each kid would get. 14 is going to go into that 4 times. So 4 times 14 is going to be 56. And if we subtract 65 minus 56, we're left with 9. So this means that of the 14 kids, all of them would get 4 pieces of paper, but then an additional 9 kids would get a 5th piece of paper, leaving 5 kids only with 4. So some of the kids have more options of being chosen than the other, so this method is not going to be fair. Now we're going to check method 2. The magician starts with the birthday boy and moves counterclockwise, passing out 70 pieces of paper numbered 1 through 70. He cycles around the circle until all the pieces are distributed. He then uses a random number generator to pick an integer 1 through 70 and chooses the volunteer with that number. So basic same idea as method 1. We're going to take 70 divided by 14 to see how many pieces of paper each kid is going to get. 14 goes into 70 5 times. 5 times 14 is 70. We're left with a remainder of 0. So this means if he passed out all 70 pieces of paper, each kid would get 5, and there would be none left over, so all the kids get an equal chance of being chosen. So method 2 would be a fair way to determine which kid he's going to choose for his volunteer. Method 3, the magician starts with the birthday boy and moves counterclockwise, passing out 12 pieces of paper numbered 1 through 12. He cycles around the circle until all the pieces are distributed. He then uses a random number generator to pick an integer 1 through 12 and chooses the volunteer with that number. The problem with method 3 is that he does not even have enough pieces of paper to give 1 piece to each of the kids. There's only 12 pieces of paper, there's 14 kids, so 12 kids would have a chance, 2 wouldn't even have a chance. So method 3 is not going to work. The only method that would work that is fair to all the kids is method 2. The last scenario we are going to discuss, in World War II, during the summer of 1944, the Russians were driving back the Germans. Stalin wanted to launch a fierce attack at one of 3 spots in western Russia: the north, the south, or the center. He also wanted to be completely unpredictable in his decision. So we're going to have 4 different scenarios. We want to determine which method or methods would be fair. Method A, Stalin learns that there is a 1/3 chance that it will rain the next day, a 1/3 chance that it will be cloudy and not rain, and a 1/3 chance it will be sunny. If it is sunny, he attacks the north. If it rains, he attacks the south. And if it is cloudy but doesn't rain, he attacks the center. This is going to turn out to be fair because for each of those scenarios, there is an equal chance of 1/3 probability that that event is going to occur. So there's a 1/3 chance he would attack the north, the south, or the center. For method B, Stalin rolls 2 6-sided dice and then multiplies the numbers on the 2 dice together. If the product is 1 through 12 inclusive, he attacks the north. If the product is 13 through 24 inclusive, he attacks the center. If the product is 25 through 36 inclusive, he attacks the south. This method is not going to be fair because there is not going to be the same number of results in each of these categories. There's going to be 36 different outcomes that could occur, but only 4 of those are going to lie between 25 and 36. We could take 5 times 5, 5 times 6, 6 times 5, or 6 times 6. Those are the only 4 scenarios that are going to give us a product that is between 25 and 36 inclusive, which means there's 32 other possibilities or outcomes that are going to be distributed between the other 2 categories, so this is not fair. Method C, Stalin flips 90 coins. If the number of heads is 0 to 30 inclusive, he attacks the north. If the number of heads is 31 to 60 inclusive, he attacks the center. If the number of heads is 61 to 90 inclusive, he attacks the south. This method is going to turn out to not be fair because if we know he's flipping a coin, there's a 50-50 shot that it's going to turn out to be heads or tails. So the number of times it's going to turn out to be heads we can expect to be around 45. So the number of heads between 31 to 60 inclusive, probably has the greatest chance of occurring, so he would probably attack the center at a greater chance than attacking the north or the south. So this method would turn out to not be fair. Now to method D. Stalin calls in 3 of his most trusted officers and instructs them to each fire at a target for accuracy. If the top ranking officer is most accurate, he attacks to the north. If the second highest ranking officer is most accurate, he attacks in the center. If the third highest ranking officer is most accurate, he attacks in the south. This method is going to turn out to not be fair as well because of the ability levels of each of his officers. They're not going to be able to shoot at a target with the same level of accuracy as the other ones. So one of them is going to be more accurate, so that outcome has a greater chance of occurring. So method D turns out to not be fair. The only method that would be fair in this case is method A.